Welcome dear students to my channel Talking Physics with Piyas Sarkar. How are you? I hope your learning goes well. So today's class we will learn about adiabatic thermal process. In the previous class I have learned you about isothermal process, but today we discuss about adiabatic process in details. That is, what is adiabatic process, what is its conditions, what is the relation between pressure, temperature, volume and work done. So keep watching my video for your knowledge, or if my video likes you, if you understand the topic, please subscribe my channel and press the bell icon. So without wasting time, we start the today's chapter, adiabatic process. What is adiabatic process? Adiabatic process is in which there is no heat exchange occur. That is, heat exchange dq is equal to 0. No heat exchange occur between the system and surroundings. But there may be change in volume and there may be change in pressure. Temperature is also changed sorry, but without given or extraction any heat from the surroundings and the system. So a system in which there is no heat exchange occur between the system and the surroundings is called adiabatic process. Now from the first law of thermodynamics we can get dq is equal to du plus dw. You all know this. अब सब लोग को ये पता ही है कि अगर किसी सिस्टम को हम बाहर से हीट देते हैं तो वो टू वेज यूज होता है. फर्स्ट इज टू इंक्रीज इट्स इंटरनल एनर्जी एंड सेकेंड इज ड्यू टू एक्सटर्नल वर्क डन. नाउ इफ दिस dq is 0, so we can get simply du plus dw, that is pressure into change in volume. For adiabatic process, the first law of thermodynamics takes the shape of du plus pdv is equal to 0. Now if volume is of the gas is expand, then what occur? When the volume is expand, when there is volume in is expand, that means the internal energy decrease. Volume expand, that means IE, that is internal energy decrease. As a result, as internal energy is directly proportional to the temperature of the system, then also temperature is also decrease. So the gas will be cooled. This is called, the gas will be cooled. This is called adiabatic cooling. This process is called adiabatic cooling. When the volume of gas expands, that is work is done by the gas. Work is done by the gas, then volume expands, internal energy decrease, temperature decrease and the gas will be cooled. This is called adiabatic cooling. When the bladder of football or the tube of cycle is burst, we get fresh cold air in our mouth because due to adiabatic cooling. The reverse phenomenon occur when the gas is compressed. When the gas is compressed. When the gas is compressed, internal energy is increased. As a result, temperature also increase. ये दो दोस्त हैं, इंटरनल एनर्जी और टेम्परेचर. ये इंक्रीज होगा तो ये भी इंक्रीज होगा, ये डिक्रीज होगा तो ये भी डिक्रीज होगा. So when the volume of gas is compressed, internal energy is increased, the temperature increase. This is called adiabatic heating. Example, when we pump into a football, then the air is compressed to the bladder. Then the football will be get heated. Or in any other example, when gas is compressed, some heat will be produced. So we know the definition of adiabatic process and also the adiabatic heating and cooling. Now we can go with condition of adiabatic process. Suppose a gas is enclosed in a container. Now, if this is well insulated, the bottom of the container or the wall of the container is well insulated, that is, it prevents transfer of heat from the gas to the surroundings or the vice versa, or from the surroundings to the container, then this process is called adiabatic process. So number one is the container or vessel wall must be insulated so that there is no exchange of heat occur. Number two, this must be a sudden process. That is, the process happens quickly. This must be a sudden process. If this will be a sudden process, then the gas will not get enough time to increase its temperature, enough time to transfer of heat, because the process will be happen suddenly. So there is no time in transfer of heat from the system and surroundings. So this must be a sudden or quick process. These two are essential conditions of adiabatic process. Now go with different relation in adiabatic process. ये मेरा जो वीडियो है ये पूरा टॉपिक का एक समरी है. अगर आप इसको अच्छी तरह से नोट कर सकते हो तो आपके एग्जाम में बहुत काम आएगा. प्लीज़ कीप वाचिंग टू द लास्ट एंड ऑफ माय वीडियो so that you can don't miss the any point. So at first we go with P and V. So relation between pressure and volume. So we can see that dq is equal to du plus dw. For adiabatic process, this will be 0, that is we can get du plus pdv. Now specific heat capacity. Cv is equal to 1 by n du dt. Therefore, du is equal to n Cv dt. For n mole of gas, specific heat capacity equal to 1 by u du dt. Rate of change of internal energy is with temperature is called specific heat. So, we can get du equal to n Cv dt. Put it in this value. Or 0 is equal to n Cv dt plus P dV. Or if we write it in this manner, n Cv dt plus P dV is equal to 0. समझ आ रहा है? Now we can go with ideal gas equation. What is ideal gas equation? PV is equal to nRT. ये सबको पता है, हम लोग क्लास 10 में भी इसको पढ़ा है तुम लोग कि n for n mole gas the ideal gas equation will be PV equal to nRT. Now if we take the differentiation, then we can get P dV plus V dP is equal to nR dt. ये समझ में आया? P fixed derivation variation of V, that is dV, V fixed variation of P dP equal to, if n and R both constant, so there would be excluded from differentiation, so dt. So you can get the value of dt is equal to P dV plus V dP divided by nR. Put the value of dt here, that is n Cv, dt means P dV plus V dP divided by nR plus P dV is equal to 0, is equal to 0. Now NCV, n will be cancel out. Therefore, Cv P dV plus Cv V dP plus P dV is equal to 0. Take the volume term in one side, that is we can get CVP, okay, we can write it in the upper side. We can get from here CVP dV plus P dV, that is PCV प्लस P, इसको कॉमन ले आ जाए, और dV प्लस V CV dP is equal to 0. Now P will be outside, P को भी PCB dV, oh PR dV, CV plus R, here CV plus R, because R is also here. So if we common the dV term, then we can get CV plus here R is included. So we can get, that is CV plus P into CV plus R dV into V dP plus that equal to 0. Therefore, we can get P CV plus R means Cp dV plus V CV dP is equal to 0. So if we divided it by CV, divide by CV CV डिवाइडेड बाई, ओके एक लाइन में कर दिया जाए, डिवाइडेड बाई PV/CV, both side PV/CV. If we divide it by PV/CV, then it will be CP/CV into 1 by V dV plus dP, CV cancel, PP cancel, that is dP by P is equal to 0. Now CP by CV is gamma, that is gamma by V dV plus dP by P is equal to 0. Gamma by P dP, gamma by V dV into dP by P equal to 0. So we can get gamma by V dV equal to minus dP by P. Now if volume change occur from Vi to Vf, I stands for initial and F stands for final, and if pressure change from Pi to Pf, therefore this term dV by V is, we can get gamma ln Vf by Vi is equal to minus ln Pf by Pi. Gamma ln Vf by Vi equal to minus ln Pf by Pi. इसको लिख लो. So we can get ln Vf by Vi to the power gamma, गामा पावर में हो गया है, इक्वल टू माइनस को अगर कॉमन लिया जाए तो दिस टर्म विल बी रिवर्स्ड, Pi by Pf, ln Pi by Pf. So ln will be cancelled, Vf to the power gamma by Vi to the power gamma is equal to Pi by Pf. Or if cross multiply occur, then Pi Vi to the power gamma is equal to Pf Vf to the power gamma, or P V to the power gamma equal to constant. This is the relation between pressure and volume for an adiabatic process. Now we go for another relation. This will be very important for doing mathematical calculation. Now we can go with the second relation, that is relation between V and T. Okay, पहले P and T, relation between P and T. So P V to the power gamma equal to quantity. This is the basic equation. From this we can establish this. So we can again know from PV equal to nRT, the ideal gas equation. P and T, that is we can say V equal to nRT by P. जिसका रिलेशन प्रूव करना है वो दोनों के ही रखना है, थर्ड टर्म दैट इज V को एक्सक्लूड करना है इन टर्म्स ऑफ P. सो वी कैन get PV to the power gamma equal to some constant. In terms of V we can get nRT by P to the power gamma equal to K. So we can get P to the power gamma, P to the power 1 minus gamma, 1 minus gamma, this is minus gamma into T to the power gamma is equal to K by nR to the power gamma. This must be a new constant, we can say it K dash. So we can get T to the power gamma divide upon P to the power gamma minus 1, डिवाइड करने से ये रिवर्स हो जाएगा, gamma minus 1 equal to constant. This is the relation between temperature and pressure for adiabatic expression. T to the power gamma divided by P to the power gamma minus 1, where gamma is the ratio of Cp and Cv. Now you can go with V and T. The main equation is P V to the power gamma equal to constant, and here we get P equal to nRT by V. So put nRT by V, V to the power gamma equal to K. So we can get T V to the power gamma minus 1 equal to constant, because this term will be also constant. T V to the power gamma minus 1 equal to constant. This is the basic law. So इसको आप प्रूफ लिख कर लीजिए अपने एग्जाम कॉपी में और प्रैक्टिस इट रिपीटेडली सो दैट you can avoid mistake. So we can get three relation. One is P V to the power gamma is equal to constant. Number 2 is T V to the power gamma. T V to the power gamma equal to, the number 2 is T V to the power gamma minus 1. T V to the power gamma minus 1 equal to constant. And the third is T to the power gamma by P to the power 1 minus gamma equal to constant. T to the power gamma by P to the power gamma minus 1. P to the power gamma minus 1, sorry. This is gamma minus 1 equal to constant. So T V to the power gamma minus 1 equal to constant, T to the power gamma by P to the power gamma minus 1 equal to constant, and P V to the power gamma equal to constant. These three are the basic adiabatic relation. Now we go with some example. Problem. If a gas at 10 atmospheric pressure and 15 degrees centigrade temperature is suddenly released to atmospheric pressure, then what will be the final temperature of air? Here gamma equal to given 1.4. If a gas at 10 atom pressure and 15 degree centigrade temperature is suddenly released, I know that suddenly release means this is none but adiabatic process. So here temperature and pressure is given, so you can know that T to the power gamma by P to the power gamma minus 1 equal to constant. We know T to the power gamma by P to the power gamma minus 1 equal to constant. So from this relation we can get how we can do this math. So from this relation we can get that T1 to the power gamma by P1 to the power gamma minus 1 is equal to T2 to the power gamma by P2 to the power gamma minus 1. Now put the value of T1 P1 and T2 P2. Sorry, P2. T2 will be find out. You shall find out the value of T2 in Kelvin. So T1 means temperature, that is 15 degree centigrade, that is 15 plus 273 Kelvin, that is 288 Kelvin. P1 is 10 atmospheric pressure, P2 is 1 atmospheric pressure. We can find out the value of T2. So T1 2 answer 288 to the power gamma by P1. P1 is 10 to the power gamma minus 1 is equal to T2 to the power gamma by P2. P2 means 1 to the power gamma minus 1. So T2 by 288 to the power gamma equal to 1 by 10 gamma minus 1. If we divided the power by gamma, then we can get gamma minus 1 by gamma. If we put the value of gamma equal to 1.4 and find out the value of T2 with the help of calculator, we can get T2 equal to 148 Kelvin. T2 equal to 148 Kelvin. In this way, we can find out the value of pressure and temperature if the three terms, that is P1, P1, P1 is given. Adiabatic work done is equal to P dV. Now the relation between if pressure changes from P1 to P2 and corresponding volume changes from V1 to V2, therefore from relation we can get P V to the power gamma is equal to K, or P equal to K by V to the power gamma, and we can get P1 equal to K by V1 to the power gamma and P2 equal to K by V2 to the power gamma. Now work done W is equal to integration P dV. Put the value of P. P means K by V to the power gamma, integration K upon V to the power gamma, volume changes from V1 to V2 dV. So K integration V1 to V2 dV upon V to the power gamma. So we can get work done W equal to K V to the power minus gamma, that is V to the power minus gamma plus 1 by minus gamma plus 1 V1 to V2, integration x to the power n dx, integration x to the power n dx, we can get x to the power n plus 1 by n plus 1. So we can get K by minus gamma, that is 1 minus gamma, V2 to the power 1 minus gamma minus V1 to the power 1 minus gamma. Now one by 1 minus gamma K V2 1 minus gamma minus K V1 1 minus gamma, K V2 1 minus gamma minus K V1 1 minus gamma. Now this is, if we break this, that is 1 minus gamma into K V2 to the power minus gamma, that is k V2 by V2 to the power gamma minus k V1 by V1 to the power gamma. What can you get? K by V2 to the power gamma means P2 and k by V1 to the power gamma means P1. So you can get 1 by 1 minus gamma P2 V2 minus P1 V1. 1 by 1 minus gamma P2 V2 minus P1 V1. And finally we get work done W is equal to, if we write it gamma minus 1, then we can get P1 V1 minus P2 V2. This is the work done 1 by 1 minus gamma sorry 1 by gamma minus 1 P2 V2 P1 V1 minus P2 V2. This is the total work done in adiabatic process. From ideal gas equation we can get PV equal to nRT. So we can get 1 by gamma minus 1 P1 V1 means N, if it N RT1 minus P2 V2 is equal to N RT2, then we can get it outside NR gamma minus 1 equal to T1 minus T2. This will be also work done. So we can get two formula for adiabatic work done. One is NR by gamma minus 1 T1 minus T2 and other is 1 by gamma minus 1 P1 V1 minus P2 V2. This is the work done in adiabatic. This is work done in adiabatic reversible process. So in this video we can briefly discuss about the whole adiabatic process. If you like my video, please subscribe my channel for new interesting video. Thank you. Goodbye. We will meet again for new video.